Hello everyone, welcome to my YouTube channel. In today's video, I'll explain you about a very important topic when it comes to programming in ESP32 microcontroller. So, what is partition table? The partition table is a file that defines how the flash memory has divided in the program. So, why it is important? When you are designing or developing a program, it is very important to uh, finalize the size of the flash memory, and you should be able to concise your whole program into the flash memory size that you have selected. So, as you know, depending on the controller, the module or the SoC you are selecting in your product, ESP32 comes with different flash sizes. So if you go to their official webpage, you can see depending on the SoC you are selecting, it comes with different flash options. So it is very important to select the required flash memory size depending on the final product that you are making using this control. So the partition table concept comes when you want to after you select the correct cache memory, and uh, there can be there will be a point where you need to edit the default partition configuration. So at that point, ESP-IDF giving an option to edit the default partition table file, and we can configure it according to our requirement. So this image is very clearly illustrate how the partition table works. So if you consider the total flash memory on ESP32, so in default configuration it is come as in this format. So in zero memory location, it is reserved for we can't define anything, but starting from the first memory address up to number 8, it is allocated for bootloader program. Then one memory point is allocated for partition table. So these are the memory address locations. So the size is defined, and you can edit the size of the partition according to your requirement. So this is the uh, default configuration, and this is the example of a partition table, that is where we have OTA configuration in our system. So I will show you how to edit this uh, file in on the IDF environment. So when it comes to partition types, there are only two. So the first type is the app. So it is app is under the app. That is the area where we uh, include our main firmware and the data. Under the data we will define the NPS size if we are using SIP or any other file system. So we can define the area in data section. So this is the example of partition table file that define the different areas of the flash memory. So as you can see, this is very important point. The NVS for the first section for the partition is starting from the offset of starting of memory address of 9000. This why this do, because the first starting from 0 to 9000 memory address that is allocated for bootloader. So when you are editing the partition table file, it is very important to start from this address. So this information is very clearly defined in the documentation, in the IDF documentation. So you can read through it and understand the concept behind the partition table, and they have very clearly explained with the example. So in the example, I will illustrate you how to do that. So I will be referring this document to do that as well. So I hope you understand the concept behind it. So it's simply a piece of file that define the sections of cache memory, and partition table will is enable us to uh, uh, allocate the memory size of the cache memory according to our requirement. So that is what simply what it does. So let's see how we can edit the partition table in our IDF in our program. We are developing the program using ESP-IDF. So I am using the simplest example, the blink example. So in previous videos I showed you how to open the example. So you just go to Explorer and show example, and under the example you can select this link and create the example file in, uh, in your directory. So since I have already created the file, I am not going to do that. So this is a very simple code. So actually you don't need to change the default partition table in this kind of programs, because the default partition table is well defined for small programs. But when you are developing a big program using so much memory and so on, so you will definitely uh, come to a point where you have to uh, edit the partition table. So if you go to configuration SDK editor, so you can see there's an option called partition table, and when you in this link program, the partition table is default defined as the single factor, no OTA. So they have given three options as default partition. So you can use these files for your uh, program, but I recommend you to use custom partition table if you encounter error message, the partition memory is not enough once you compile it. So how to do that? So what you have to do, let's say once you create a big program, when you try to build it, there will be a error message saying that partition active memory or NVS memory is not enough to compile. So once it happens, you go to SDK config and you go to partition table and you change into custom partition table CSV. So once you do that, you can see the custom partition. You can give any name to this file. So this is basically a CSV file. Define the but how should the partition should be mapped. So you can give any name, but I keep the default name like this, and you can see the offset starting from this value, and then you save it. But it is not defaultly create. It's not creating a partition file automatically, even after you save the configuration. So after you save the configuration, what you have to do is go to view and go to command palette, and here you type ESP32 ESP-IDF, and you can see the list of commands will stored here. So under the list, you can find a command called Open Partition Table Editor UI. You just click it. So as soon as you select that command, you can see in the default file path, there it automatically creates a file called partition CSV. So then after, what you have to do is you can edit this table according to your requirement. So we'll refer this uh, documentation example in this case. So you can see uh, the in this example for NVS or for non-volatile memory space, it allocates memory like this. So we'll use this example for in this case, but after you read this documentation, you can understand how we can divide into other sections as well. So let's see how to do that. So just go to this UI and select add new row, and it is essential to have this names when you are editing adding the editing the partition table. So the name is NVS, the data type it is the data type, but it is under the subtype it is NVS. The offset is this value. So likewise, I will be adding these other section to this file. Data is physical offset this value. So in this example, it is clearly calculate this offset value. But if you want to edit the area of this section, you can change the up. You can calculate this offset accordingly. So for an example, once you allocate this amount size to NBS, the starting for memory address should be after this much of offset. So if you increase this size, then the starting address should be shifted according to this memory size. So you can do the math and calculate the offset. So let's add the factory size as well. Go to factory and M. So this means for our main program, we have allocated 1 megabyte size from the cache memory. So that is basically the meaning of this line. So if I repeated it, so for our main program, starting from this address, it allocates this 1 megabyte memory address for this program. So this can be edited according to your whatever the program you make. So this is only for example purpose. So once you add this, you just save it and go to this, select this file. So you can see it has updated according to our what we have edited before that. So you can even you can edit these values from here as well if you want. So that is it for configuring partition table, and after that you can just build the program. So if the allocated memory is enough for compilation, so then the compilation process will continue without any issue. So I hope you get the basic concept of the partition table. If you have any question regarding this, please comment down below. I will help you to figure out the problem you have. So I hope this video will help you to understand this concept, and that is it for today video. I thank you for watching my video, and please subscribe and like this video. That will help me to do more videos, and it is encourage me to do more videos. So thank you very much and have a wonderful day.